I'm going to kind of go over some of just a general discussion of key mining risks. I'm just going to introduce myself quickly. So I'm Adrienne Berchtold. I'm an aquatic ecologist. I studied at Simon Fraser University, and now, like Nikki said, I work for SkeenaWild Conservation Trust, and my focus is on researching mining impacts in BC on water quality and salmon habitat, and then implementing that into advocacy to improve mining practices and policy. Next slide. So why should we be concerned about mining? Well, it's a large-scale extractive industry. These projects are massive. They drastically alter the landscape, and they expose lots of potentially polluting materials. And like we've already heard, most of the sort of critical minerals mining in BC that is occurring and is likely to occur will be for open pit copper mining. So it'll look something like this. This is Copper Mountain Mine in the Similkameen River. Next slide. And these projects are often in really close proximity to natural water bodies. So this is the Red Chris Mine in the Skeena Watershed. And you can see in the background sort of some natural fish-bearing lakes immediately downstream. Mines also produce a large volume of tailings that need to be managed. It's waste that is produced by the mine. Usually it's stored in a large water-covered facility, and that's held back by earthen dams. Next slide. So some of the key mining risks, the first one really is just the disruption to other uses of land, and that starts way before we get to those big mines that I was just showing, right? Like that happens with claim staking, through exploration, then the operation of the mine, and even during reclamation. In BC, these activities are really prioritized over pretty much all other uses of the land. And so some of the other uses of land that get disrupted would be, traditional use and governance by First Nations, could be local land use plans, recreation and tourism, or it might be other climate mitigative strategies like carbon sequestration that we're no longer able to do. And then the other second sort of probably most significant effect of mining is the impacts to aquatic habitat. We can kind of break that down into 3 different categories. So mines directly alter or destroy aquatic habitat. Often they're built right over top of aquatic habitat, fish-bearing streams or lakes. And if not that, then often streams or rivers are rerouted to make space for this infrastructure. The second way that mining impacts aquatic habitat is that they change water flows and temperature downstream. So a lot of water gets used and diverted for mining, and then it might get discharged somewhere else. So those changes to water flows and inherently that can alter temperature as well, that really affects the quality and the availability of habitat for fish. So I'm thinking about, salmon spawning habitat, for example, can be significantly impacted. And then lastly, we know there's a significant risk of chemical pollution to water, can get into fish tissue, aquatic vegetation, etc. Then there's also some other impacts. So mining disrupts critical habitat. It might impact endangered species and biodiversity. In BC, we've had a lot of that occur through, actually coal mining specifically has severely impacted endangered caribou herds throughout the province. And lastly, maybe on the more extreme end, you might have impacts to human health. It might affect drinking water sources, air quality, and then also our food sources, right? Our fish, our wildlife. Next slide. This is a map that we worked on dealing with the water pollution impacts of mining, where we sort of cataloged all the past and present mine sites in BC according to whether or not they pose risk of water pollution. You don't really need to see the icons. I'll kind of go through the main results, which were that we found 173 sites, or evidence of 173 sites across the province. And of those 116, or 67%, about 2/3, there was strong evidence that they have either already contaminated the surrounding aquatic environment or they pose the risk to do so. And of those, acid rock drainage, which is a particular type of mine pollution that has very low pH in the water, very high levels of metals, was a risk at 71 of those sites, so quite a few. A lot of the other sites were data deficient. There just is no public data on whether or not they pose a contamination risk. And actually, we only found information on 2 of those 173 sites, so 1% of the total, where we could say confidently that there was no risk of water contamination. So from that, we basically concluded that it's safe to assume that basically all mining in BC will pose some risk of water pollution. Next slide. And then this is just a close-up of the Northwest region where we are now. This is an area with a lot of active interest, a lot of activity around copper mining, and the vast majority of the sites in this region have that risk of acid rock drainage, so that more severe form of water pollution. So that's sort of a really big concern when we talk about expanded copper mining up here in the Northwest. Next slide. Another sort of general risk that I wanted to discuss is that mines are really complex projects, and as thoroughly planned as they may be, they usually don't go to that plan. And a few examples of how this might look are that you might have a water surplus, so you end up getting too much water at a mine site. You might have a water deficit, not enough water at a mine site. There are cases of both of these situations occurring right now as we speak at mines in BC. And when that occurs, the mine design and the mine infrastructure doesn't operate as planned, and that increases the downstream risks. It increases the chances that the mine is not going to be able to mitigate its impacts in the way that they said they would. The next way that things don't go as planned, and we know all about this from multiple sites in BC, is failed reclamation, so failed cleanup. A lot of the time, this has happened due to insufficient reclamation bonding, which BC is still dealing with and is trying to improve, but still has a long way to go. But another way that this occurs is that a lot of these mining projects are in very remote and hard to access locations. That makes it difficult to bring the infrastructure, the personnel, the materials over the long term to make sure that those sites are managed in perpetuity and cleaned up to the degree that we expect them to be. And then the last one, obviously, and this is going to be spoken to in more detail by others on the panel, but there's the risk of catastrophic dam failure. And we know that that can have severe consequences downstream to both habitat and to human life in some cases. Next slide. I'm just going to go into that in a little more detail. So this is a simulation. I didn't work on it. It was done by a firm called Linker Technologies. But they simulated what a tailings dam failure at an existing BC mine site would look like. And so the mine location, this is a real mine that exists, is in the red circle in the top left. And then they modeled the tailings run out and the mine water that would be released and how far it would spread. And it's in blue. It goes all the way down, all the way to the bottom of this map. It's hundreds of kilometers that would be potentially affected. And in this case, it would cross the US border as well into creating transboundary impacts. Next slide. So another project that we worked on with BC Mining Law Reform is this BC Mine tailings map, where we cataloged all of the tailings facilities in BC and tried to look at dam failure risk. Next slide. So we've found that there are already 172 total tailings dams across the province. And importantly, there are already 6 of those that are in the top 30 tallest tailings dams in the world. In addition to that, there are 3 that are proposed to reach heights that will be in the top 10 of the tallest tailings dams in the world. And this is relevant because peer-reviewed research has shown that the higher a tailings dam is, it can increase the risk and the consequence if it fails. We also found that there's currently a total of 2.5 billion cubic meters of tailings waste stored across the province. And just to kind of maybe try to visualize such a large volume, that is equivalent to 1 million Olympic-sized swimming pools. So it's a vast number. And that amount will potentially increase by up to 75% with the 11 proposed tailings facilities that when we made this map a couple of years ago were sort of on the docket and being pushed forward. Again, this is relevant because the greater the volume of tailings that's stored, the greater the consequences of a dam failure. And so digging into that data a little more, next slide. We also, when we looked at the data over time, we sort of found that basically the cumulative risk of tailings failure is increasing in BC, and that's for a few different reasons. So these facilities are essentially permanent on the landscape, right? Like BC is not really doing very much to reduce the inventory of the facilities that could potentially fail. And so as more and more dams get built, we just get more and more dams, more and more facilities, and a larger volume of tailings on the landscape in facilities that could potentially fail. And then we also found that in addition to that, the size of these facilities is increasing over time. So they just keep getting bigger, the dams are getting taller, the volume of waste that's being produced and stored is getting bigger as well. And then lastly, climate change really exacerbates these risks. So again, peer-reviewed research has shown that extreme precipitation events are often implicated in tailings dams failures. And BC is seeing more and more of those extreme precipitation events. Next slide. So that's sort of the larger landscape of risk. And I'm just gonna talk quickly about sort of what the mines that are being proposed in Northwest BC really look like sort of what's coming down the pipe. And I'm going to talk about KSM as a case study. So this is a mine, copper and gold, silver, I'm not sure what else they're proposing, but open pit mine that will be in the headwaters of both the Unic watershed and the Nass watershed. And this is just a photo of the area that will be developed if and when the mine is built. Next slide. And then this is the site map of the mine. So down here in the bottom left is where the open pits, and there's going to be some underground mining infrastructure as well, will exist. They're right in the headwaters of the Unic River, which is the transboundary salmon-bearing river. And then across, all the way across a mountain range, will be their tailings facility. And that's going to be in the headwaters of the Belle Irving River, which is a major tributary to the Nass. So the first thing to say about this mine is it's massive. It's going to be one of the largest open pits in the world. It's spread, like I said, across 2 separate salmon-bearing watersheds. And just that sort of scale inherently increases the risk and potential impacts of the project. They're also proposing to use wet tailings. That increases the risk and the consequence of tailings dam failure. It's going to need perpetual water treatment, hundreds of years of treatment to address the acid rock drainage and the elevated selenium in the water. And that's risky because there's really no guarantee that those systems will work and be maintained for hundreds of years into the future. And lastly, this has already been alluded to, but gold is going to be a main product of that mine. And so I think really the concern there, and this is very common in BC, in the Northwest in particular, is that projects are going to move forward under the sort of banner of critical minerals development when potentially really the value to the companies and like the focal product of the project might not actually be something that we need for the renewable energy transition. And so how much of the disturbance and the impact caused by that project is for, copper that's going to go into EV batteries, et cetera, and how much of it is going to go into precious metals mining that we really don't need. So yeah, next slide. The conclusion, surprise, mining is risky. There's no doubt that we need to move off of fossil fuels. However, all of this research and information that I just shared, I think really points to the fact that there are a lot of reasons for us to try to reduce energy demands in order to reduce the demand for critical minerals, use alternative sources of critical minerals beyond new mining as much as possible, require less risky mining practices and much stricter oversight by our governments. And then also, ensuring that the critical minerals strategies that are being developed and implemented right now by our province and by our country and internationally for a lot of you who are working in those spheres, really prioritize risk management and reducing the risk over these sort of opportunities for financial gain that I think are the priority of a lot of the people pushing forward those strategies. Yeah, I'm just going to stop there. Thank you.